Part C, use the remainder term, which is Rn, to estimate the maximum error, which is the absolute value of the Rn as a bound on the error in the approximation of the function f of x equals natural log of 1 minus x by p3x, which is the Taylor polynomial with n equals 3, in the interval -1/2 and 1/2. By the estimate of the remainder theorem, the absolute value of the Rn is less than or equal to m multiplied by x minus a to the power n plus 1 divided by m plus 1 factorial, where m is the maximum of the absolute value of the n plus 1 derivative at the point C. C is between a and x. In this case, a is 0, and x is between -1/2 and 1/2. Using the Taylor polynomial of the degree 3, so n equals 3, we are going to estimate the maximum error R3, which is less than or equal to m times absolute value of the x minus a is 0, or the absolute value of the x to the power 4, divided by 4 factorial. So we're going to find the m and then complete the inequality later. So next, find m, where m is the absolute value, the maximum of the absolute value of the fourth derivative at the point C. From part A, the fourth derivative of the function at the point C is -3 factorial divided by the value 1 minus c to the power 4, and take the absolute value. Now we're going to find the appropriate value c that will give us the maximum quantity for this absolute value. Since c is between the value a, which is 0, and the value x, which is -1/2 and 1/2, the value c equals 1/2 will give us the maximum quantity of this, the fourth derivative at the point C, which is -3 factorial divided by 1 minus 1/2 to the power 4, and the number come out to be 96, which is the value m. Now we get m as the maximum value of the fourth derivative at the point C. Then we're going to estimate the error using the Taylor polynomial of degree 3, which is less than or equal to m, which is 96, multiplied by the absolute value of the x to the power 4 divided by 4 factorial. And since x is between -1/2 and 1/2, so we get 96 multiplied by 1/2 to the 4th power over 4 factorial, and give us 0.25. So that means the absolute error, which is the difference of the exact value and the approximation, which is P3, is between -0.5 and -0.25 and 0.25, or we can write it as f of x minus P3 x -0.25 on the left, 0.25 on the right. So the function value will be between the P3 of the x, or the Taylor polynomial approximation with the degree 3 minus 0.25, and the Taylor polynomial degree 3 added by 0.25.